All right. So a radian. Okay, we have radians and degrees to measure angles. Okay, you all know how to measure in degrees. You guys are very familiar with measuring in degrees. Radians might be a little uncomfortable for you. So let me remind you what a radian is. Okay, the measure of a central angle that intercepts an arc S equal in length to the radius. Oh, I forgot a D there. Radius. Okay. Okay. So basically, when your arc length equals your radius, then you have one radian. Otherwise, we have kind of a ratio, if you will, of arc length to radius. Okay. Now you are probably used to radian measures being in terms of pi, right? Does that sound familiar? Okay, let's talk about why you remember them in terms of pi. Okay. So here we have a circle. Okay. How do we find the arc length of an entire circle? What? Okay, that would be the number of radians. Mm-hmm. That would be the number of degrees. What? Okay, pi d or 2r times pi, right? So our circumference is 2 pi r, which can be considered the length of that arc of the entire circle, right? And so if we think about a radian measure, we take arc length divided by radius, right? And we get 2 pi. That is why a complete rotation is 2 pi radians. Okay. This also means, okay, so this is the same as 360 degrees. If 360 degrees is the same thing as 2 pi radians, then 180 degrees would be the same as pi. Okay? And that is the fact that we use to help us convert from degrees to radians, radians to degrees. Okay? So that's the first thing that we are going to remind ourselves of. If I have a degree measure, okay, this is simply just a conversion problem. If I want this to be in radians, we need to multiply by what? I don't want degrees anymore. I want degrees to cancel out. Yes, I know that pi radians is the same thing as 180 degrees. Okay? If we multiply by pi over 180, then our degrees cancel out. Okay? And we're left with radians. So how many radians? Okay, well, I know those zeros are going to cancel, so we have 12 pi over 18, which reduces to what? What?
2/3.
2/3. So 2 pi over 3. If there is not a degree symbol, then we assume that it's radians. Pi doesn't mean it's radians. There's no degree symbol, so we assume it's radians. We see often pi as a part of a radian, but it doesn't have to have a pi if it's a radian. It just doesn't have the degree symbol. Okay, let's go the other way. 7 pi over 9. If I want to know what that is in radians, how are we going to convert that? Okay, let's multiply by 180 degrees over pi. Okay, so we now have degrees. Conveniently, our pi's cancel out, and we are left with 140, because we have that 0 here. 140 degrees. Just a conversion problem. As long as you can remember that pi radians is the same as 180 degrees, which you'll remember by the end of this, you can convert. Okay. All right, let's talk about graphing angles in standard position. Who can tell me what it means to have an angle in standard position? Maybe not the word I'm looking for. Where do we start our... Great. We're going to begin at the positive x-axis, and then we rotate, right? This would be a positive rotation. If it's negative, which way would we rotate? Describe it to me. What is this? Clockwise. Okay, so counterclockwise is a positive rotation. And a negative rotation would be clockwise. Okay, so we'll always start with the positive x-axis and then rotate from there. Okay, so we call this our initial side, and then we rotate and put a terminal side somewhere. All right. Now, let's just remind ourselves of the quadrants, because you could be asked what quadrants does this angle lie in. So let's just remind ourselves. We've been, taking a break from math for about 2.5 weeks now. So what quadrant is this? And 3. Okay, so we name them like that. Okay. Okay, so I'm going to use these. We're gonna plot some angles. Okay. Now, before we plot these two, let's talk about what our degrees would be as we rotate in the positive direction. So if we begin here and we rotate positively, what would this degree measure be? 90. We start at 0. We'd rotate to here, 180, and to here, and then all the way back to 360. So if I were wanting to plot 120 degrees, where would we plot that angle? What quadrant would it lie in? Quadrant 2 would be about here. I always like to make kind of that arrow as I rotate to know that I rotated positively to get that angle. Okay. All right, let's talk about negative 750. I'm just going to erase all of this. Okay, you might want to you can plot these on the same axes, or you can draw a new one. I don't care, or a new pair of axes. Okay, negative 750. First of all, we're going to start here, and we're going to rotate, which way? Clockwise. We're going to rotate. One time around would be, okay, there's negative 360. Then what? Another one. Another time around would be how much? 720. So how much, excuse me, how much more do I need to rotate? Okay, so we've rotated negative 360, negative 720. So a negative 30 degrees, and there's our angle. We plotted angles last year in Algebra 2, right? Okay, excellent. Let's do the radians, okay? Let's talk about if we begin in standard position, we begin at 0 radians. And we know 1 time around is how many radians? 2 pi. Okay? So, how many radians would we rotate here? Great. Half a pi or pi over 2. And rotating all the way here to the other side of the x-axis would be pi, because that's the same as 180 degrees. Down here to the negative y-axis would be 3 pi over 2, okay, 1.5 pi's, right, but we're going to call it 3 pi over 2. And then, like we said, all the way back to 2 pi. So if we wanted to plot 5 pi over 2, first of all, is that greater or less than 2 pi? It's bigger than 2 pi, right? So we're going to go 1 full rotation and then another half pi. Five halves is like 2.5, right? So we went 2 pi and then another half pi. 4 pi over 3. Matt, what quadrant do you think that would be in?
It's less than 2, so I would give you 4.
Or it could be in 3. So 3 or 4. Is 4/3 pi closer to 1 pi or to 2? Well, and is 4/3 bigger or smaller than 3 halves? Is what we have to ask ourselves. Smaller, so it would be in quadrant. Excellent. So there's 4 pi over 3. Okay. Some of you may be in the habit of converting to degrees and then plotting them. I want you to get to a point in this chapter to where you don't have to convert every single time. Okay, we're going to work with radians so much, especially when we get to the unit circle, that you're not going to have to convert every single time. Okay? If you need to in this section to kind of get used to things, that's fine because it doesn't take that long. But my goal is that you don't convert. You can just understand where these angles need to be. Okay. All right, let's talk about some geometry words. Okay. I'm going to give you about 20 seconds to talk amongst your pod about what it means if 2 angles are complementary and what it means if 2 angles are supplementary. All right, pod 4. That'll be you. What does it mean to be complementary? Okay, angles. Oh, we'll say 2 angles. add up to 90, just 90 degrees, thank you. Okay, if you don't put degrees, I assume it's radians, so you have to say degrees. I know that's being picky, but we got to think about these things, okay? If I wanted radians, 90 degrees is the same as
1/2 pi over 2.
okay, or pi over 2 radians. Okay, we are going to have to do this for both degrees and radians. Okay, supplementary, pod 2. Okay, 2 angles add up to 180 degrees, or how many radians? Pi radians. Okay, are you okay with my shorthand? But I just put a plus sign instead of an. Is that okay with everyone? Okay. So, I am fully confident that you can find complementary and supplementary angles in degrees. I'm not going to go over an example of that. I feel like you can handle that without me doing that. What I would like to do is go through an example of a radian measure. Now, if an angle is over 90 degrees or over pi over 2 radians, can it have a complement? No. Okay? If it's over 90 degrees or pi over 2, we cannot have a complement. Okay? We don't have a negative angle to make a complement. Okay? So keep that in mind. So let's talk about 5 pi over 12. Let's first of all find its complement. If 2 angles add up to pi over 2, means they're complementary, how would I find the complement of 5 pi over 12? Subtract it from? Okay. We're going to take pi over 2 and subtract 5 pi over 12. Okay, if it helps, you may need to change pi over 2 to a fraction that has denominator 12, which means, so we have 6 pi over 12 minus 5 pi over 12, which is pi over 12. That is its complement. Supplement. If 2 angles add up to pi radians, means they're supplementary. How do we find the supplement? Subtract from pi. What is the supplement? 7 pi over 12. Yes.
Since we're able to rotate it negatively, are we going to have to deal with supplementary and complementary of those two as well?
Angles that are complementary are going to be positive and acute. Angles that are supplementary will be positive sometimes, well, most often you'll have one acute, one obtuse. Okay. Does that make sense? What his question was? Okay. Now, here's where we get into some negative angles and angles that are more than one rotation. Okay? Coterminal angles. Okay, I know that you have talked about this before, but this is something that it's possible you forgot. So what I want you to do is, in your pod, I want you to break down the word, coterminal. If you don't remember what it means, talk about what you think it could mean. I'm going to give you about 60 seconds.
goes over, like, over 360. There's like a way. Yeah. It all comes from one hand.
Okay, I hear a few different things being discussed, so we'll see what pod 1 has to say first.
Like angles that end at the same like spot on the axis, like 360 and 720, they both end at the same spot.
Okay, so co-terminal. Right.
Ending together.
Okay, right. I'm hoping you break it down. Okay, so angles that end at the same spot. Would that make sense with co-terminal? No? Okay, he's right. I did hear you guys were talking about an angle and what's left in the quadrant.
Yeah.
You're thinking of a reference angle,
Oh.
and we will talk about that next week. Okay, but a good thing to remember. Okay, so. Okay. So coterminal angles are angles with the same initial side because we start in standard position all the time, but really they're sharing the same terminal side. Okay, and just to reiterate, this would be our initial side, this would be our terminal side. I know I informally talked about that, but I'll put it up there in case you need that visual. Okay. So, we're going to talk about a couple different angles. We'll start with degrees because it's often easier to visualize degrees because that's what you're more familiar with. So, 70 degrees. What quadrant does that lie in? Quadrant 1. Okay. It's okay. We're still getting warmed up back from break, right? So there's 70 degrees. Okay. I want an angle that ends at that same spot. How could I find that? Okay. I heard two different answers. So I'm going to go with Michaela first. What did you say? And how did you get 430? Okay, if we take 70 degrees and we add 360, so we rotate 70 degrees and then we rotate 360 more, we're at the same spot. So 430, yes, would be a coterminal angle. Matthew, what did you say?
I said take like 360 minus 475.
Which one is it?
Thank you.
You are right. With one of those.
Yeah.
Matt's trying to figure out, is it 360 minus 70 or 70 minus 360? It is 70 minus 360. We always want to start with the angle that we're at and either add on to it or subtract from it. Okay, so, all crazy here. This would be negative 290 degrees. That would be a coterminal angle. We could go on for a very long time naming coterminal angles. There's an infinite number of coterminal angles. We can say 430, and then what could we do with that? Add another 360 to it for 790 degrees. And then we could add another 360 and another 360. Okay, we can keep going on and on and on. And same thing with the negative angles. We can keep subtracting 360 from that previous coterminal angle. Okay? So your book may ask you to find like two positive and two negative coterminal angles, keep adding 360 until you have two positive. Keep subtracting keep subtracting 360 until you have two negative. Okay. All right, let's talk about radians. First of all, 3 pi over 4 is our angle. What quadrant would that be in? It'd be in the second, because remember this is pi. 3/4 of pi would be less than that, right? This is pi over 2, so 1/2 pi. 3/4 would be exactly between 1/2 pi and 1 pi, right? So here is 3 pi over 4. Okay. To find coterminal angles in degrees, we added or subtracted 360. To find coterminal angles in radians, what are we going to do? Add or subtract 2 pi. So let's start with, here is pi over 2, and we're going to add a full rotation. So what is 3 pi, oops, I don't know what I said. We're going to start at 3 pi over 4 and add a full rotation. And what would that new angle be? What would that red angle be? Great. 11 pi. Adding fractions, first day back. Okay. And then if we wanted to find one maybe in the negative direction, we could take, well, how do we do that again? I can't remember. Okay, so start with the angle and subtract 2 pi. And what would that angle be? -5 pi. We're going to get to plot some angles today. Okay. Are there any questions before we move on to our next set of videos? Everything we've talked about so far has been just like a reminder of something, right? Okay. The next 2 items we need to discuss, once again, they're reminders. Okay. First, I want to talk about arc length. How did we define a radian? What did I have you write down? The radian theta was the ratio of arc length to radius. I had you write down arc length to radius. Okay? I want you to look at that for a second. The next thing we're going to talk about is arc length. Here's the formula for arc length. Does that look familiar? A little bit, right? Okay, it's just a rearrangement of theta equals S over R. We multiplied R over. And now we don't have a fraction. We have S equals theta times R. Now, since we used the definition of a radian and rearranged it to get S equals theta times R, theta has to be in radians, then you are finding arc length. So if your angle is in degrees, you must convert it to radians if you want to find the arc length. Okay? Arc length is referring to the piece of the circumference that is cut off by that central angle. Okay? So what's highlighted in red up there is the arc length. Do you remember back in geometry when we had all of those theorems about circles and like central angles or inscribed angles in circles and what the measures were. Remember all that? That was fun. I have like this big puzzle that I gave my geometry kids. They have to figure out all these different measurements. Obviously, it wasn't something that really stuck with you. Huh? Okay, example. I want the arc length cut off by a central angle of 30 degrees in a circle with diameter of 3.6 inches. Okay, so we want this arc length right here. Well, arc length is theta times radius. 30 degrees. Do we plug in 30 degrees? No, we do not. So theta is 30 degrees, but we want to convert that to radians. How do we do that again? I want to get rid of degrees, so I'm going to multiply by something where degrees is where? In the denominator. And what's the same as 180 degrees? Pi radians. So our degrees cancel. So our arc length is pi over 6 times 1.8 inches. Okay, 1.8 because our diameter was 3.6. So Kyler, you have your calculator out. What is pi over 6 times 1.8?
0.94.
Okay. Arc length is a measurement. We took radians times inches, so we have inches. One last concept, and then I'll give you time to begin your homework. Okay. So this slide we talked about how to find the arc length of a piece. Okay. Now I want to know the area of what we will call it a sector. Okay. So same concept where we have an angle cutting off a piece of our circle. Okay. To be able to find the area of that piece of pie is what I'm going to call it because that's what it reminds me of. We just have to take 1/2 theta r squared. Now, how do we find the area of an entire circle? Pi r squared. And how many radians would be in an entire circle? 2 pi. So if I found the area of an entire circle, we would have to take 1/2 times 2 pi times r squared, which is pi r squared. Okay, so formula seems like it'll be okay, right? Okay. So last example, we have a sector formed by a central angle of 15 degrees, and it has an area of pi over 3 square centimeters. Find the radius of the circle. Okay, so we know that our angle is 15 degrees, and we know our area is pi over 3 square centimeters. Now, same thing, our angle needs to be in radians, so we will convert it by multiplying by pi over 180 degrees, which means our angle is 12, right? Well, let's think about it. If 30 degrees was pi over 6, then 15 degrees would be pi over 12, right? Okay, so area of the sector, 1/2 theta r squared. So our area is pi over 3, could equal 1/2 times pi over 3 times r squared. So let's clean this up. Let's write this as pi over 3. Oh, why did I write pi over 3 over here? What should it be? Well, I'm sorry. There we go. That's what I want. Okay, so if I clean it up, we have pi over 3 equals pi over 4 r squared. How do we get r by itself? Okay, divide, and since it's a fraction, we can say we're going to multiply by the reciprocal. Okay, so over here we're left with r squared. What do we have over here? 8. Okay, so to solve this, we need to take the square root of both sides. Technically, r is what? Plus or minus radical 8. What is r representing? The radius. Can a radius be negative? No. So we're not going to worry about the negative. Our radius, and we probably want to simplify this, is 2 radical 2, and what would the label of the radius be? Centimeters, because we know our area was square centimeters. Alright? So here is your homework. Things are going to go about the same as they did last semester, where I'm not going to grade your daily homework, but I will ask you about how it went. Your daily homework is important for your success, so you need to make sure you're staying on top of things. Okay, this should be a fairly easy assignment for you because a lot of it is review. Tomorrow we're going to talk about right triangle trigonometry. Before we do that, I'll ask you about how this assignment went and any questions. I haven't decided yet. I might get everybody new clickers because I know we have some that have lost them. I have people who have moved classes, so I may just do new clickers. Okay? How many people don't know where theirs is? Yeah.